What we're going to do is get into a little bit about the stick-built to conventional frame, as well as I think I'm probably going to challenge you all a little bit, particularly the lumber producers downstream, because there's some things here that I think we can do that can really help our industry a lot. First off, just to give you a little bit of background, I've been the executive director of SBCA since 1992. We went through a downturn in 2007, lost 1,000 component manufacturers. At the height of SBCA, we were at about 800 component manufacturers, about 1,200 locations. You can notice that there's consolidation, 449 component manufacturers and 769 regular members in terms of the locations, so that's consolidated. At the height of our industry, we're probably about 10 billion. We're probably doing about 5-6 billion these days, and probably about 5 billion board feet of lumber, 5-6 billion board feet of lumber. 239 suppliers, and there's a lot of growth potential. So our job at SBCA is really best practices oriented, really to support the component manufacturers in the development of the market. We also have a Framers Council. Framers Council is really tied very nicely to the framework, structural components. Clearly, we talked this morning about labor and the labor supply issues. Components help that. There are still a lot of stick-built construction going on, but the framers have a desire to have a safe environment. Componentization will help that safe environment. This is just an emerging, we started this in 2013, it's an emerging association, and really ought to, I think, help us a lot, because the best thing that we can do as businesses is understand our customer. And our customer is the framer in this particular case. If we're going to make productivity increases, we better understand how they put structures together. We do that well. We do the engineering of that well. We're going to increase the componentization. We're going to increase our productivity dramatically. So I'm just going to share with you a little bit of a engineered for change thought process, just for fun. Oops, sorry about that.
He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I won't run an EEG on, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer. There.
So engineers are important. They're very low on that scale of potential jobs, but actually we need to think about that. And we need to think a lot about that with respect to where we're headed, because if we're going to innovate, engineering and technology becomes darned important. And I'm going to share with you some things that we learned in Frame the American Dream. We did this in 1995. I won't play the entire video, but I'm going to play some of it. We did it again in 2015. And this information is up in the public domain on our website, something that's useful. But we'll go through this a little bit systematically and take a look at, this is just a time-lapse video.
Trust Council of America, in association with the Building Systems Council of the National Association of Home Builders, presents Framing the American Dream. This educational demonstration project took place at the 1996 Builder Show in Houston, Texas. Two identical houses were completely framed at the same time using different construction techniques. The purpose was to compare the costs and the efficiencies of component construction and stick framing. Final calculations showed that the component-framed house required 253 fewer man-hours and saved more than $3,300 compared to the stick-frame version.
You can see that was a little bit dated. We were with Trust Council of America a long time ago. We're now the Structural Building Components Association, and we did this in 2015. That was not perfectly timed. It was at the Astro Arena. Obviously, we're using 2 video cameras. This one's perfectly timed, and this will be interesting to watch. And then the next slide that we'll get into is some facts that are important. This has no audio with it. Take a look at that. There's the floors are complete. Look at where you are on the stick frame side. Pretty dramatic. Those are floor panels, by the way. These are wall panels with foam sheathing, spray foam, eventually. So if you take a look at that, we've got half the roof on, and we're still getting the floor deck on. And again, that's perfectly timed. Our technology is much, much better today. So trusses go fast. There's a lot of efficiencies there. It's pretty astounding. So when you take a look at the efficiencies in the labor utilization, it becomes fairly obvious. If you're going to cycle time involved and you want to make money, there's really only one way to do it. So the question is, why is it hard to sell that? And we'll get into that in a second, in multiple ways. So we're still going. Same speed. And we're not that far away. These guys, the framers on the left-hand side, they knew how to frame. They framed it very efficiently. It just gives you a real good sense for performance differences. And it gives you a real good sense for time, because we've been talking for a couple of minutes here, and obviously that's the kind of time difference, right? Well, what does that mean? 1995, 401 hours, 148. 2015, 375, 152. Really, the fact of the matter is, the framing process hasn't really changed. Our waste, we're a little bit better at waste. We're about the same in board footage. So 1995 to the present, from a Framing the American Dream perspective, and we did that on purpose, was to understand what's going on. Why are we not at 100% market share? Well, part of the problem that we've got, take a look at this slide. And it's from the Builders NEHB. The central point here is Slow evolutionary change is a hallmark of the U.S. construction industry. Stick-built houses, it's the same. You start panelizing, of course, trusses are part of the stick-built, but panelized walls, probably about 15% of the market. Trusses in multifamily, 75%, roof trusses, floor trusses, 25%, single family, about 70%, floor trusses in the single family market are less than 5%. So you end up having, again, this whole panelization notion. We should be seeing a lot more than we have. Take a look at poured concrete. Why are we not doing more wood? I mean, I've got a wood, all-weather wood foundation in the house that we built. Very, very nice application. Why don't we have penetration there? You can pick that up. It's a lot easier to frame. You can hoist in wall panels real easy. You can put a foundation in just as fast as you can do trusses. So what's going on there? We have seen some increase in rafters. So the labor savings is going to be something that's very, very helpful. So Wisconsin's all trusses. The North is all trusses. Why is that? It's cold. It's faster. You can get things done faster. You need to be indoors quicker. But in the South and Texas, you're still stick framing roofs. Major builders are moving more and more towards cycle time. D.R. Horton is going to be using trusses if they can systematize it. But if labor costs don't pay anything back for the use of trusses, builders are reluctant to change, because if typical labor and the typical labor process is, I'll give you $1,000 a frame. In fact, one of our executive director, Chris Tachi of the Framers Council, he works with us part-time and runs dynamic construction in Madison. And what they typically do is they have the framer give them a fixed fee, $3,000 to frame the house, and whether they do it in 2 days or 10 doesn't make any difference. And so obviously when you have that kind of construct, it's really hard to have the business model take into account the value proposition that components provide. But trusses have seen some of that value proposition, right? Because it's difficult to frame roofs. It's difficult to cut roofs. We don't have that technology or skill set much anymore. And obviously with the labor supply issues, if you want to construct a lot of buildings, a lot more buildings, componentization makes sense. But then you go to this, and you don't see floor trusses really growing in market share. You see I-joists have replaced concrete, makes a lot of sense. And I-joists have done a good job, and that's one of those innovative products. Truss joists back in the middle 80s went to distribution. I was part of that particular process back in the middle 80s. And once they went through distribution, that became kind of a commodity. But one of the problems that we've got in the lumber industry is we're a commodity. We don't think value add. In fact, this past weekend I was in Boise, sat down with Sherm Nelson, who's now 83, who's vice president of engineering in the mid-80s when I was there. And he ended up, Truss Joist was very good about value add, making margins, creating differentiation through innovative products. We don't do that well in our industry. We got to get better at that. It's a big deal, a really big deal. And here's why. Take a look at this. What's changed? What's really changed? That roof is a KB roof in our test facility. So we did testing, but take a look at that gable end. Take a look at the gable end on top. What's changed? This is basically the 1900s. Francois said, back 1930, it goes back to late 1800s. Nothing's changed. Absolutely nothing's changed. Raw materials, have they gotten better? I don't think so. Manufacturing, CAM, computers, 1980, we have Apple Computer, right? That's changed. But did it make construction better? If we're part of the construction industry, we're part of the lumber industry, could we do the engineering in this industry to take and put a man on the moon? Do we have kind of that innovative spirit? Engineering, we've gotten better with computers. Delivery, GPS, yeah, there's a lot of technological changes. We were just talking about framing. Framing productivity, how do we improve that? How do you automate construction on the job site. How do you do that? We have one manufacturer, Barry Dixon and True House in Jacksonville, put in an automated truss manufacturing operation. His biggest problems are lumber twist and non-square dimensions, and plates that aren't, if the plates aren't manufactured dead flat, if he shuts down the line, he can do a truss every 30 seconds when the line's running with 4 guys. So he can do, in fact, we'd like to get to the point where we could do truss manufacture with no guys. Problem is we don't have the raw material to do it. If you're going to manufacture things, you have to have consistent dimensions. Truss plates have to be consistently flat. If there's any curvature at all due to the die process, screws up automation. We're not talking now, 3/32 of an inch tolerance. We're talking thousandths of an inch tolerance. It's a problem. We have to think through, all of you have to think about your raw material differently. It's a big deal. So we've got, can we get to the artificial intelligence and robotics that we need? What are our constraints? Are building codes our friend? Can we engineer and innovate? All those things are real questions. We take a look at our raw material, and this is a big deal. And it's probably going to, for those that produce lumber, this is probably the most important piece of the conversation. The pieces on the left-hand side are testing that we did, and it's number 2 material, southern pine. And one of the things that, and so we just deal with lumber and plates, right? I put that out there on purpose because there's a bit of juvenile wood in that kind of 700 pieces that we got in from truss manufacturers. But here's the important point. Let's just kind of take and spend a little bit of time on this. Design values in PS20. If you're an engineer, here's what you have to work with. Published design data, this is the definition of design values in PS20, I'll emphasize that again. So this is your standard. Published design data that represent strength and stiffness of specific grades and species/species groups of lumber. What does that mean? If you're an engineer, what does that mean? Published design data that's representative. Now, let's dig into this. This is the Appendix A of SPIB. What is a natural product subject to variations of geography, climate, etc.? Its strength properties are not only anisotropic, vary by principal axis, but can also vary by proximity to the center of the tree. These characteristics complicate the assessment of individual pieces into design value groups based on visual appearance. This value that's established becomes a design value. Designers of wood structures are cautioned to take into consideration the variability of wood within a species and grade grouping. Each piece of or lot of visually graded lumber is not mechanically tested to verify strength properties. If you're an engineer, which I am, and we have done about 90,000 truss designs a month in our shop on the DRJ engineering side. If you're an engineer, how would you feel about this notion? You build a car, and you've got a steering wheel, you got brakes. And as the driver of that car, you're cautioned to take into consideration that the steering wheel might have variability, and the brakes might have variability. How would you feel about that? There's an opportunity here. There's a huge opportunity here for differentiation and providing reliable design properties. Designers of wood structures should be able to rely upon design properties. If we can't, how in the heck do you do innovation? And it gets a little bit worse. Catch this. And I just ran into this in litigation. I do a lot of defense work, component manufacturers. This is GP's, Georgia Pacific, so you can go to that website and take a look at their terms and conditions. And under further handling, it says, Buyer shall indemnify, defend, and hold harmless the seller. So I'm buying lumber. I get to defend and hold harmless the seller, its affiliates and the respective officers, directors, employees, etc., against any and all claims, losses, liabilities, costs, and expenses, including attorney's fees arising out of or resulting from the use, handling, manufacture, processing, alteration, distribution, sale, or marketing of the goods, or any other action or inaction with regard to the goods. So what does that mean? That means if I buy that lumber, guess what? I own it, and I own all the liability. That gives you confidence, doesn't it? As an engineer, does that give you confidence? As a builder, we're building 14-story wood buildings. I get into litigation to defend a component manufacturer, guess what? This pops up. We didn't know it. Absolutely had no idea. It's under further handling. Try to find it. Do a Google search and try to find terms and conditions. Point being, there's a lot of headwinds here, but headwinds are what? They're opportunities disguised as a challenge. And that opportunity is, you know what? We'd like to have reliable properties. We really would. We need them if we're going to engineer things, if we're going to innovate. There's another bit of headwind. We're our own worst enemy. There's 4 parties that really are problems for us. NAHB, AWC, American Wood Council, APA, and ICC. They are responsible for holding us back, keeping us in barefoot and pregnant, effectively. It's a bad cliche. The IRC defines OSB performance in this way. Shear walls. We tested a 12 by 30 foot building. I'm told in our building that that building's wrong. Test is wrong. Sitting there saying, shoot, this 12 by 30 foot building, I have a building official in here and all day long, it's going to pass the code. In fact, it's built perfectly to the code. You know what the design value assigned for 4 by 8 sheet of OSB 6 feet off the corner with gypsum in the IRC is? 840 PLF. You know what the tested value is? 450 PLF. A factor 1.7. How do you innovate if you have a 1.7 factor better than the design properties? How do you innovate? Well, I brought this to APA. And again, I'm going to give you some challenges here that I face. Brought it to APA. Here's what Ed Elias in a letter to me, and I can show you the letter if you want it. Anybody that wants a letter, give me a call. We believe that a major goal of SBCA and what we were trying to do in that conversation was get that factor 1.7 and have a level playing field. We believe a level playing field is the right thing to do, and reliable properties is the right thing to do. Here's what Ed said. We believe a major goal of SBCA is to provide a cost-effective engineering solution to their membership, and as such, this goal serves the SBCA membership well. However, by establishing standard factors, level playing field, in which product equivalency or system performance are applied generically, an unintended consequence may be that non-wood products, foam sheathing, gain an advantage and supplant traditional OSB market share. It's called competition. This is not in our association's best interests. I'm sitting there saying, you know what? If you got a 1.7 factor advantage, so in other words, let me put this in real terms. I'm 175 pounds. So I have another person that's 175 pounds. I get to carry another 1.7 times and have a race. OSB has, remember that 1980s or 1800s building? Why are we stuck there? Because the building code favors tradition. NAHB favors historical performance. You talk to any engineer in the country to try to do residential design and engineering and do engineering better than the IRC, can't do it. Can't do it. Because you've got built-in competitive advantage to incumbent traditional products. So, where do we go? Is there an opportunity? There's always an opportunity. Think about this. Think about what we don't know. This is a test, 70-pound weight or 60-pound weight dropped through 3 feet. If we drop that 60-pound weight through 3 feet, what's going to happen? What's the load on those load cells? There's 2 load cells up there. What do you think that load is? Is it, it could be a real question if you want to answer it, but it could be twice. So 60, 120, it could be 500, it could be 1,000. Who knows, right? So what do you think it is? £2,112 pounds. Okay, that's acceleration physics, right? And that decays pretty rapidly. You notice with the decay, you see that peak at 2,112 and it decays. But how many of you would have guessed 2,112? Therein lies what? The value of engineering. So how do we make innovation happen? We understand load path. We actually can innovate. We have some headwinds in that innovation. But if we end up having reliable properties, and I would encourage all of you to think very seriously, there is an opportunity here. If you're going to deploy our engineering community's intelligence, and I'll give you the flip side of that, most engineers don't know, and they would be horrified if they found out that the NDS design properties that they put in equations are this variable. They'd rather have it be that variable. So the risk here is steel. The risk here is an alternate material. If I had an alternate material that ended up having reliable properties at a consistent cost for a year, that would penetrate the component manufacturing industry in a New York second with a warranty. Think about that. That's a challenge that is wrapped in an opportunity for somebody. Because we need, think about a business. What do we need? We need reliable properties because you're going to test that. You know what happens every time when we test a structure? That 130,000 pounds of load on it, that roof. 130 pounds per square foot, 1,000 square feet roof. Where'd it break? Not. Slip of grain, every time, guaranteed. It's a fuse. If I could have a fuse like that in all of our designs, it'd be a great thing because I could design around it. But what do? Repair it. Load it up again. Where's it break the next time? Not. Bottom cord tension. Slip of grain, not. So that's kind of reliable. It's a good thing. Always breaks at a knot. If we didn't have a knot, guess what? We'd probably be stronger. But think about the business model for a second here. What do we need in our industry to have a great business? If you end up having a business, you're a component manufacturer. And right now, component manufacturers, we could lose a component manufacturer too. Why? When lumber runs from $400 a thousand to $600 or $700 a thousand, and you got a fixed contract for a quarter, at 50% of the cost of the product, if that lumber runs up 20%, that's 10% off the bottom line. It's a 10% loss. Our biggest fear with the executive committee in our industry right now is going out of business because they don't have enough cash. Because lumber is a raw material that is like this. When you think about business, what does Wall Street want? Wall Street wants consistent profits every quarter. How do you do that as a truss manufacturer if lumber's going like this? Not very easy. If you have reliable properties, we can actually engineer sophistication in. So we have double whammy. We have unreliability on our costs, and we have unreliability on our raw material. So that's a challenge, right? We live with it every day. It's fine. We'll deal with it. But it's a challenge wrapped in a disguise called opportunity. Because if somebody changes that, or if an outside industry changes it and brings an alternate to lumber, which we'd love to have, that would be a great day. Reliability, consistent cost. We go for that like a New York second, like I said. But there's an opportunity here. As Francois said, what do? Windows. Windows and branding, decks. They've increased market share. Well, they've increased market share because why? Because they provided greater value than a wood deck. And they branded themselves. Take a look at Huber. What has Huber done with Zip? They followed a Trust Choice model. Kirk Koch, I knew from Trust Choice days. They branded it differently. They've got great value. They're growing a great business. We need to do more of this. When we did testing back in 2011 with ProBuild, we ended up transforming the engineering of that particular roof. And through the downturn, ProBuild put 6% on the bottom line through calibrated engineering. There's room to move. I wish I had a little bit more room to move in the OSB front, but there's room to move. We need partners that think about our industry in an engineering way, teaming up with component manufacturers to make a big difference. And that difference is not going to happen with a commodity mentality. I'll guarantee you that. What'll happen with a commodity mentality is if there's an opportunity, someone else will change this industry permanently. So, do we have an opportunity? What's our future? Here's our future.
A 2-minute video isn't long enough to explain the evolution of an industry that has been around since the 1950s. But if you're looking for a job that matters, if you're looking to make a difference in your community and how it's built, if you're looking for an opportunity to take on real challenges, grow, learn new skills, and be rewarded for your hard work, take a look at the structural building components industry. Roof trusses, floor trusses, and wall panels play an integral role in many of the structures you see every day, from the house next door to the strip mall down the street to the new dorms on campus. 3/4 of all residential structures built today include components, making it an $8 billion a year industry. But the companies in this industry don't just help build communities, they are communities. The individuals you meet in this industry are here for a reason: to solve problems using state-of-the-art technology, to get their hands dirty putting together the framework of their neighbors' homes, to share in the successes of an honest day's work. And many have an interesting story to tell about why they started and why they've stayed. They tell stories about pride and passion. Some are jobs that turned into career paths they never knew existed. Each truck that leaves the yard represents someone's dream: a home, a business, a local organization. Playing a role in turning those dreams into reality can make all the difference in the world. There's a need for a wide variety of talent in every component plant in every city in this country. From designers to component builders, salespeople to sawyers, IT professionals to truck drivers. No matter what your background, if you have a passion for solving problems and building things, this industry has a place for you.
So our future. I think we have a great one. But it's going to take this and a heart with passion to innovate. And really, what we got is we really need all of you desperately to think about how do we change our business models? How do we end up teaming up to make innovation through engineering and manufacturing a priority. If it's not a priority for our raw material suppliers, we'll push that envelope. But if it's a priority for somebody else that's going to supply us raw material, you're going to have a heck of a lot of help. I can guarantee you, our door's open. Our industry's door's open for guys and gals that want to think, want to step out of the box and make a significant difference in this industry. That's our future. We've got a bunch of young kids coming in, and they're very bright. We can build something really special, but we got to team up, and we got to care about one another, and you got to care about your customers. So that's all I've got to say. So thank you very much.